walkthrough on how to run the Fractal service locally on your machine. The goal of this walkthrough video is to showcase how you can run all of the different Fractal services on your local machine, which is particularly useful if you want to do a demo of it or if you want to do some testing with the whole Fractal service running locally for you. To be able to follow this walkthrough, you will need to be able to run Docker containers on the machine that you're planning to test this in. The rest we will be simulating within these containers. But be aware that this is not meant as a production setup. There's some limitations to the data access within those containers, and the cluster that we reconfigure in one of the containers to really simulate how Fractal would work is configured to be very tiny. We have past videos that are linked in the description where we have examples of how you can set up Fractal server and Fractal web very manually by setting up the correct Python environments and building Fractal web from source. This video is really focused on giving you a faster walkthrough through how you'd use all of this by using our containerized approach for it. And the main thing you want to go to is to our Fractal containers GitHub repository that is also linked in the description. And in that repository, we have different examples. The one we walk through today is what we call the full stack example. By running the full stack example, you will get a few different containers set up on your machine to be run. The first one is a Fractal server container. This one will run the actual backend server for you. We have Fractal web server container that will run the front end server for you. The vSAR container will run our viewing service so that you can visualize the OMSRs that Fractal can process. The file browser is meant to give you some easier data access to get data in and out of the containers. And then the Fractal server container also runs Slurm in this container so that there is a tiny little cluster that simulates how Fractal would normally interact with a Slurm cluster. And there's a Fractal database container that runs a Postgres database that is used by Fractal server. Now, to use any of this, you will need to follow this 7-step example. First, we want to clone the Fractal containers repository, and we want to go into the examples full stack folder that is in this repository. In that one, you can just have Docker start the containers. So we do Docker compose up. Now what this will actually do, we can show here, is we have a little Docker compose file in the example for the full stack, and it will set up all of those services that we need to run Fractal. So for example, the Fractal web service with a given version, the server configuration, the file browser, etc. And you configure things like, for example, how big your Slurm is by configuring Docker Compose. Now, this startup can take a minute or two if it needs to download all of the base images that we build on here. Once it is up, you can visit the Fractal web frontend. So you see this. In the Fractal web frontend, you can interact with this as just your local service. You can log in to this Fractal service using these default local admin credentials. That is certainly not something you'd want to have configured this way if you'd ever open this up more broadly. And now we have access to an actual Fractal service. We could go to the Fractal splash page to learn more about the framework. But in this case, let's try and run some actual workflows. But before we can run workflows, we need to have some task packages available. Fractal has a whole overview of packages that exist. In this example, we'll run a workflow that just needs some tasks from the task core package. And to install this, we need to install the Fractal task core package in a given version if you want to specify it, with a given extra of Fractal tasks. So on the server, in the task section, we can go to task management, put in the package we want to install. We can select a Python version if we want to, and we can give the extra of Fractal tasks that this task here needs, and send this for collection. Now the collection of Fractal task core will take approximately 5 minutes, depending a bit on your internet connection and machine speed, because this needs to install Torch and other Cellpost dependencies. From the web interface, you can also go to the examples folder, and there's a little scripts folder in there. In this scripts folder, you could follow the instructions here to create a little Python environment that contains the Fractal client, and then trigger task collection by just using the little script that will trigger the same kind of task collection we triggered here. And eventually this will finish after about 5 minutes. So now we have a Fractal server with a whole set of tasks available that we could run. Let's run an actual example workflow. So for that, give it a name, and in this example project, we create a dataset. Let's just call a little demo dataset, and we will do a workflow. In this case, in the Fractal containers, in the full stack example, we have in the scripts folder an actual workflow example, so we can just use that one. This workflow example consists of 3 steps: converting some data that's already available into an UMSR, projecting it from 3D to 2D, and then running some Cellpost segmentation. We could change any of the parameters of this workflow as we'd want, and then we can run the workflow. In this case, this workflow is now run locally in our simulated little Slurm cluster. In a real production deployment, of course, these workflows are sent off to the actual cluster for processing, while offering monitoring here in the web interface to show the user whether a given task has been submitted, and will show up when these tasks finish, or would also show when any of the tasks fail. What we can see in this example is that it first ran the conversion, so it took our microscopy data from a vendor format and made it into an UMSR. Second, it will run a projection where we chose a maximum intensity projection, which is also finished. And third, we'll run some segmentation using the Cellpost model and the pre-trained Cyto2 model with some parameters we configured for this workflow. Once this workflow has run through, we could of course go further and process the data further. If we want to use very interactive viewers like the Nepari viewers locally, we'd have to download the data by using the file browser service that we're also running here. And these images here will be in the subfolder, and in this demo folder we'd have 2 images, and we might want to download. Once the workflow is already finished, we might want to say we want to download one of those SARs, but instead of moving the data back and forth, what we can also do is visualize our images that come from this workflow directly in the web viewer that we have running in the Fractal VSAR viewer container. So now that Cellpost has finished, we can go back to a project view, and in our dataset we see that we have a 3D image and a 2D image, and we can decide, for example, to view our 2D image and browse around it, interactively rescale it, etc. So hopefully this demo could show you an example of how we set up the whole Fractal service to run locally in your machine as a bunch of different containers that need to be run. And these containers then make sure that the backend service is running, a cluster is simulated for you locally, you have front end running with Fractal Web that you can use, and a data viewer service that you can also interact with. And in this whole setup, you can collect tasks, any of the available Fractal tasks from any of the packages, create data sets, create workflows, run those workflows locally, as long as they run on your machine with the configuration we made for this little tiny Slurm cluster, and see their output. For more information, follow along on the Fractal overview page to learn more about the framework, its tasks, and its other development.